Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. In a prior episode, I covered computing coordinates. Today I'm taking a deeper dive as a precursor to an upcoming episode on arranging complex diagrams. I'll describe how to arrange nodes and coordinates relative to one another without any explicit coordinates. I'll explain how to compute a linear combination of coordinates to get a new coordinate. I'll show how to use anchors and shifting for moving around your nodes and coordinates. I'll show how to pick the x value from one coordinate and the y value from another, and then even some more involved inline calculations where you can do things with the x and or y coordinates of various points. These are a whole bunch of different positioning tools that you may find useful. This video is based on my book, Unlocking LaTeX Graphics. This channel has many other videos as well, and I'll link to some of those that are most relevant in the show notes. Here's the preamble for today's episode. I'm using geometry package to set the page size. I'm using the hyperref package to link the author name back to the YouTube channel. The key package is, of course, TikZ. I'm also using the positioning and calc TikZ libraries. The first thing I'm going to do is some setup and then a simple TikZ picture. I use TikZ set to specify some things that will apply to my picture. I append the every node style to specify a sans serif font in large, center alignment, drawing the outline in blue, and filling the node with yellow at 20%. The node distance is something used by the positioning library. It specifies the vertical and then the horizontal distance. I'll explain this in more detail as we get going. I also have here a very simple TikZ picture with a single node. We compile that and we see what we get over here on the right, just a single node with the text, "An apple a day keeps the doctor away." Now let's add a node using the positioning library. So here I'm positioning a node B to the right of A. So let me compile that and we'll see what happens. This right of A comes from the positioning library. Notice that A does not have parentheses around it. This is one of the rare cases where you reference a node name but without parentheses. This puts the left edge of B exactly 20 millimeters from the right edge of A. I'll add the next node, C, below right of B. So when I compile that, we get a new node over here. Its upper left corner is 20 millimeters to the right and 5 millimeters below that of the lower left corner of the node B. These distances are from the specification of node distance up here. The default is 10 millimeters by 10 millimeters. I'll continue by adding two more nodes to finish up our basic picture. I'll put a node D below left of C and a node E to the left of D, and we'll see what we get here. Now, this is kind of a funny alignment because the nodes are different shapes. I did that on purpose so that we can try some other alignment techniques. We just saw an example of using the positioning library. Now let me use the calc library. I'm going to use it to draw a frame around the picture. I could do that just using the corners of the current bounding box, but then it would be too tight. I want to expand the frame a little bit, and the calc library makes this easy to do. So let me paste here the frame command. So I'm going to draw a frame with rounded corners, ultra thick. The secret is I'm taking that upper left corner, current bounding box dot northwest, plus a specific coordinate, minus 0.5 plus 0.5. So it's bumping out the coordinate a little bit to the left and a little bit up. The magic is I have to put open parenthesis $sign at the beginning and $sign close parenthesis at the end. Then I'm using the rectangle command, and then I'm doing something similar to the lower right southeast corner. I'm bumping out an additional 0.5 in the x direction and minus 0.5 in the y direction. When I compile that, we get our frame with a little bit of extra space. Suppose I want to align the top two nodes at their tops. Rather than using the positioning library, I can use node anchors and shifts. So let's go back and look where we declared node A and node B. And I'm going to replace this declaration of node B with something a little bit different. Here I'm creating the same node B before, but instead of just saying it's to the right of A, I'm setting its anchor to be the northwest. I'm saying it's at the point A dot northwest. That means its northwest corner goes here, but then I'm shifting it to the right by 25 millimeters. When I compile that, you see that we get now that the tops are aligned. Next, I want to center node E under the node A. I can do that by using the positioning library, but just changing the option. So I'm going to go to my declaration of node E, and then I'm going to paste over that with below equals 20 millimeters of A. Rather than using the distance that's specified up here, which is only 5 millimeters of vertical distance, I'm telling it manually how far to go. So we go 20 millimeters down, and it's centered with respect to node A. Suppose I want to align the node D with the bottom of node E and the middle of node B. First, let me go ahead and move this node to be below node E because I can't align it with respect to node E if E is declared afterwards. Next, I'll change the node options of where it goes. So I'm going to paste over these. And I'm saying it's above this point I'm specifying, which is E dot south and B dot center. And I'm using this dash bar in the middle. This means to take the Y value from the left coordinate, the E dot south, and the X value from the right coordinate, B dot center. If I were to swap the order of the dash and the bar, that would mean to take the X value from the left and the Y value from the right. I always get these confused, so it usually takes some trial and error. But when I compile that, we see now this node is above this point, which has the same Y value as E dot south and the same X value as B dot center. Next, I want to center node C vertically between nodes B and D, and then over a little bit to the right. To set up for this next bit, I'm going to move the definition of C below all the other nodes because it's going to need to reference them to get its positioning. Now I'm going to do something really different, and let's see if I can explain. I'm pasting here a very complex statement. I'm creating a path, and then I'm using the special keyword let. And then the partner to that is this special keyword down here, in. Between those, I am using some special macros. If you do /p followed by a single number, then this defines a point, and you can later reference that point or its specific X and Y values. Here I'm letting the point P1 be the point B dot south, and I'm declaring P2 to be the point D dot northeast. I can then access their X and Y values as /x1 /y1 for the first point and /x2 /y2 for the second point. Next, I can make a calculation involving those values if I want. That has to be preceded by a /n. That means it's something calculated. I'm just computing the midpoint between the two y values, so it's y2 plus y1 minus y2 divided by 2. So I'm putting this into this /n macro, which can hold the result of a calculation. Then this in keyword says I'm done assigning points and doing calculations. Now I can use the pieces. So I'm going to use the x2 value from the node P2, which is this corner. Then I'm going to use the n3, which is this midpoint, so to put it here. And then finally, I'm shifting it over by 10 millimeters. So let's recompile that and see how it goes. And now you can't see a huge difference, but it is indeed in the middle. Lastly, I want to demo the way to get a point on the line between 2 points using a coordinate calculation. I'm going to go down here after I draw the frame, and I'm going to define a coordinate named midpoint that is at the halfway point between E dot southeast and D dot southwest. I'm naming that midpoint. The way that I've done that here is with this exclamation point, 0.5 exclamation point in between two coordinates. And then I surround the whole thing again with that open parenthesis, dollar sign, close parenthesis. This is another type of coordinate calculation. Instead of just sort of a plus or a minus in between, you can have this exclamation point, some fraction, and an exclamation point. Now that I have that, I'm going to draw a line from the current bounding box dot south y coordinate and the x coordinate from the midpoint from the bottom to the top. So let's compile that and see what happens. So I'm using again that special dash bar notation to pick out the two different x and y values from the two different points. I hope you enjoyed today's episode on coordinate calculations. If you learned any new tricks, post a note in the comments. This video is preparing us to recreate a complex diagram in a future episode. I hope it gives you a sense of the many different tools that you have to compute coordinates and position nodes or coordinates in your TikZ picture. As a reminder, most of these tools need either the positioning or the calc libraries, so be sure to include those in your header if you want to use what I've shown you today. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PGF plots questions, please post them in the comments. If you want to learn more, check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.